Hi, welcome to another video. So we're going to review for the final in this video. So I give you a practice final online, and so let's go through the solutions of this practice final. Okay. Keep in mind these are only practice questions. These are not the questions that will be on the final. There will be different questions. Okay. But hopefully this will help you gauge whether or not you can answer final like questions. Okay. So, practice final question number 1. It says calculate the definite integral. So we have a definite integral from 0 to pi of sine x plus secant x times tan squared x over tan x dx. Okay, and so to do this, let's separate this into two separate integrals. So this is equal to the integral from 0 to pi of sine x over tan x. For tan x, I'm going to write it sine x over cosine x. So it's sine x over tan x dx plus the integral from 0 to pi of secant x times tan squared x over tan x dx. Okay, so just right there, two separate, the sum of two integrals because of that plus sign, right? This divided by this plus this product divided by this. Okay, so the signs cancel, and 1 over cosine x is equal to cosine x. So that's the definite integral from 0 to pi of cosine x dx. And this is plus the definite integral from 0 to pi of secant x. And then tan squared x over tan x is tan x dx. Okay? An antiderivative of cosine x is sine x. So this is sine x evaluated from 0 to pi. Plus an antiderivative of secant x tan x is secant x. And so it's plus secant x evaluated from 0 to pi. And so sine x evaluated from 0 to pi is sine pi minus sine 0 plus secant pi minus secant 0. And this is equal to sine of pi, which is 0, minus sine of 0, which is 0. 0 minus 0 plus secant of pi. I think of secant of pi as 1 over cosine pi. Okay. And cosine of pi is negative 1. So this is 1 over negative 1. So secant pi is negative 1 minus secant of 0. Secant of 0 is 1 over cosine of 0. Cosine of 0 is 1. That's 1 over 1. Secant of 0 is 1. So this is negative 1 minus 1. So 0 plus negative 1 minus 1 is negative 2. And so our definite integral is equal to negative 2. Okay? Okay, good. Next one, number 2. Okay, so for number 2 in the practice final, we have evaluate the integral by interpreting it in terms of areas. So we want to find the value of this definite integral by interpreting it in terms of areas. So let's graph this function. So it's y equals the absolute value of x translates to the right by 4. This is y equals the absolute value of x minus 4. It's the absolute value, y equals absolute value of x translates to the right 4. And so this point is 4 comma 0. And so we're going to get the integral from 0 to 8. So this is 8 and that's 0. So the height of the function at 8 is 4. Absolute value of 8 minus 4 is 4. The height at x equals 0 is the absolute value of 0 minus 4, which is absolute value of negative 4, which is 4. So the height of that is 4. That's 4. And that's 4. 1/2 base times height, the area of that is 8. 1/2 base times height, the area is also 8. And so the area of this triangle is 8, and the area of that triangle is 8. And so that definite integral is the area of this triangle, which is 8, plus the area of that triangle, which is 8. And so you get 16. So that definite integral is equal to 16, interpreting it in terms of areas. Okay, so again, y equals the absolute value of x minus 4 is just a translation to the right by 4 units of the absolute value, y equals absolute value of x, which would be here. And you move to the right 4 units, and it looks like that. So that's number 2 on the practice one. Okay, so next one, number 3. Number 3 is estimate the area under the graph of y equals 2x plus 3x cubed plus 3x squared from x equals 0 to x equals 8. Okay, so we want estimation. So let's do this. So y, we have so we have the x-axis, we have the y-axis, 2x minus 3x squared. So across the x-axis at the origin, 0, 0. And if you write y equals 2x plus 3x squared, and you factor out the x, you get x times 2 plus 3x. And you set equal to 0. You'll either get x equals 0 for this factor, or x equals negative 2/3 for that factor. Okay. So we want it from x equals 0 to x equals 8. And so we want the graph under it. So however this graph looks, so however this graph looks, we're just going to integrate it from 0 to 8. And so we're going to estimate it, and we're going to use 4 approximating rectangles, and we're going to use right endpoints. Okay? And so we just need to find the heights of the function at those x values, and then multiply them by the length of each subinterval, right? And then we'd approximate the value of the graph. So I could give you a rough estimate of the graph probably, but I'm going to take a little while for me to do, and you don't have to do when I get against this problem. So the area under y equals 2x plus 3x squared from x equals 0 to x equals 8 is approximately, we're going to use 4 approximating rectangles, and we're going to use right endpoints. Okay. Okay, so I'm going to include that in the sheet here. I'm going to say n equals 4 right endpoints. So you'll see that. That's what you'll see in the sheet. Okay, so this is approximately, this is f of x. And so it's going to be, if you have the interval from 0 to 4, and you divide it into 4 subintervals, then you just have 1, 2, 3, 4 there, right? And you're going to use right endpoints. And so you just take the value at the right endpoint of each subinterval. So this is approximately f of 1 times 1 plus f of 2 times 1 plus f of 3 times 1 plus f of 4 times 1. So you plug in 1, and f of 1 is 5, plus f of 2, which is 4 plus 12, which is 16, plus f of 3 is 6 plus 27, which is 33, plus f of 4, which is 48 plus 8, which is 56. Okay? Each times 1, so you're just adding the values f of 1 plus f of 2 plus f of 3 plus f of 4. Okay. F of 1 is 5, f of 2, 12, plus 4 is 16, f of 3, 27 plus 6, 33, f of 4, 48 plus 8, 56. Good. So you add up those numbers, and you get 21, 54, 110. Okay, so we approximate it using 4 approximating rectangles and right endpoints, and we get 110. All right, so that's number 3. So number 4, use logarithmic differentiation to find the derivative of this function. So y equals x cubed plus 4 squared ln of x divided by x to the 7th. X cubed plus 4 squared ln of x over x to the 7th power. Okay, so we're going to use logarithmic differentiation to find the derivative. Take ln of both sides, that equals to ln of y. ln of y equals ln of x cubed plus 4 squared ln of x over x to the 7th. That's equal to ln of the numerator, x cubed plus 4 squared ln x minus ln of the denominator, x to the 7th. Okay, so this is by the second law of logarithms. This is equal to ln of x cubed plus 4 squared plus ln of ln x minus ln of x to the 7th. This is equal to the sum of those two ln's by the first law of logarithms, right? ln of this times this is ln of that plus ln of ln x and minus that. Now this is equal to, moving the exponent in front, this is equal to 2 ln of x cubed plus 4 plus ln of ln x minus 7 ln of x, and this is by the third law of logarithms. So just move the 2 in front here and the 7 in front there. So what I have now is that ln of y is equal to that. Differentiate implicitly with respect to x. So ddx of this is 1 over y times y prime equals ddx of that, which is 2 times 1 over x cubed plus 4 times the derivative of x cubed plus 4, which is 3x squared, plus ddx of this, which is 1 over ln x times the derivative of ln x, which is 1 over x, minus 7 times ddx of ln x, which is 1 over x. So 1 over y times y prime is equal to that whole thing. Then solving for y prime, you get y prime is equal to y times all of that. And y is that. So this is y cubed plus 4 squared ln x over x to the 7th times that whole thing. So 2 times 3x squared is 6x squared over x cubed plus 4 plus 1 over x ln x minus 7 over x. Just simplifying a little bit. Okay, and that's y prime. That's y prime using logarithmic differentiation. We took ln of both sides and we expanded using the laws of logarithms. So that's step 1. Step 2, we differentiate implicitly with respect to y. And then step 3, we solve for y prime. And we're done. Okay, so we took ln of both sides. We expanded this using the laws of logarithms as much as we could. Then we differentiated both sides implicitly with respect to x. Then we solved for y prime by multiplying both sides by y. We got y, which is this, times all of this, which is that. Okay, and so that is the solution to number 4. Okay, let's keep going. So number 5, find a formula for the inverse of the function. Y equals 6 plus 4x over 2 minus x. Okay, so you cross multiply, you get y times 2 minus x equals 6 plus 4x. You have 2y plus xy is equal to 6x. 6 plus 4x. So this is a minus sign. Okay, now we're going to move the terms to the x on one side. So I'll move the x terms on this side, and the 6 I'm going to move on the other side. Okay, so I want to keep things positive. So I'm going to move the xy to the right, and 4x plus xy, and the 6 to the other side, 2y minus 6. I'm going to factor out the x here. So this is x times 4 plus y. So I have 2y minus 6 equals x times 4 plus y. And that means x is equal to 2y minus 6 over 4 plus y. Okay, so x is equal to 2y minus 6 over 4 plus y. I've solved for x explicitly in terms of y. Switch x and y. Y is equal to 2x minus 6 over 4 plus x. When you switch x and y, the new y is f inverse of x. Okay, f inverse switches the x and y coordinates. And so when you switch the x and y coordinates here, the new y is the new y of the inverse function. Okay? All right, so that is f inverse of x. That's number 5. Okay, so we just solved for x explicitly in terms of y, switched x and y, the new y is f inverse of x. Okay, step 1, solve for x explicitly in terms of y. Step 2, switch x and y, your new y is f inverse of x. Okay, that's number 5. Number 6. Calculate the differential. Differential from -2 to 0 of 2t squared times the square root of 1 minus 4t cubed dt. And so 1 minus 4t cubed, let u equal that. So let u equal 1 minus 4t cubed. Du is equal to -12t squared dt. So we have a 2 squared dt. And so what we need is to multiply this by -6. And so it is defined from -2 to 0. The square root of 1 minus 4t cubed. Instead of 2t squared dt, we want a -12. So I'm going to multiply this by -6. So -6 times 2t squared dt. And if I multiply the inside by -6, I'm going to multiply the outside by -1/6. So I don't change the value of the definite integral. Is equal to -1/6, the definite integral from -2 to 0 of the square root of that is the square root of u, and then -6 times 2 is -12. -12t squared dt is du. Let's see, get that. Next, I'm going to switch the limits of integration and get rid of the negative sign. This is going to be 1/6 the integral from 0 to -2 of u to the 1/2 du. I just wrote this using an exponent, and I switched these two and made the negative go away. Okay. So now this is equal to an antiderivative of u to the 1/2 is u to the 3/2 multiplied by 2/3. And then that's times 1/6 and evaluated from 0 to -2. Okay, and so this is equal to 1/9 times -2 to the 3/2 minus 0 to the 3/2. Oh, wait. Oops. Okay, wait. Backtrack a second. Okay, so when I substitute for u here, I have to change the limits of integration. When t is -2, you get 33 for u. When t is -2, -2 cubed is -8. -8 times -4 is positive 32. Plus 1 is 33. So you just plug in t equals -2 there. You get u is 33. When t is 0, then you get u is 1. Okay, so now these are the limits of integration. So you switch the limits because you get rid of the negative sign. You go from 1 to 33. Now this is good. Okay, so now this is equal to 1/6 times 2/3 u to the 3/2. That's an antiderivative of u to 1/2. Evaluate from 1 to 33. Okay, and so this is equal to 1/6 times 2/3, which is 1/9. So it's 1/9 times 33 to the 3 halves minus 1 to the 3 halves. And so this is equal to 1/9 times 33 to the 3 halves minus 1. And that's it. And that differential is equal to 1/9 times 33 to 3 halves minus 1. Okay? That's number 6. Okay, let's keep going. Number 7. Okay, so if $3,000 is invested at 4% interest, find the amount due to the nearest cent at the end of 6 years. If the interest is compounded daily. Okay, so A naught is equal to 3,000. And the rate is 4%, which is 0.04. End of 6 years, so T equals 6, which represents number of years. And the interest is compounded daily, so N is 365. N is the number of times interest is compounded per year. If the interest is compounded daily, then N is 365, right? The formula is the final amount to A equals the initial amount A naught times 1 plus R over N to the N T. Okay, so you just plug in. So A is equal to the initial amount, 3,000, times 1 plus R, 0.04, over 365, raised to the 365 times 6 number of years. So this is equal to 3,000 times 1 plus 0.04 over 365, raised to the 365 times 6, which is 2,180. Let me just check to make sure. 365 times 6, that's 36, 39, 21, 2190. I was up with 10. It's 2190. Okay, so 365 times 6, 30, 36, 39. Oh, good. Okay. So you put that in your calculator and you get the answer. So the final amount is 3,000 times 1 plus 0.04 over 365 raised to 2,190. So you just have this formula. And you need to know A naught is the initial, that's 3,000. R is 4%, 0.04. T is 6 years. Interest compounded daily means interest is compounded 365 times each year. So N equals 365. You don't consider leap years, just a regular year, 365. Okay, so interest compounded daily means there's 365 days in the year, and N equals 365. Okay, so you just plug in 0.04, 365, 3,000, 365, 6 there, and you just calculate it and get the answer. Very simple. You just need to remember this formula to get the answer to this problem. Okay, so this is compound interest question. Okay, it could also be continuous, right? If the interest is, that's for daily compounded interest. If the interest is compounded continuously, use this formula. This is for continuously compounded interest. Then the final amount A is equal to the initial amount A naught times e to the RT. The T is the number of years, R is the rate of interest, A naught is the initial amount. All right, so A naught is still the initial amount. R is the rate. Okay, and T is the time in years, right? Time. And so this is for if interest is compounded continuously. Continuously compounded interest. Continuously compounded interest. Okay, so that's for continuously compounded interest. This is for if it's compounded n times, not continuously per year. All right, that's number 7. Let's keep going. Number 8. Number 8, use the limit definition of the differential to evaluate this differential from 1 to 3 of x squared minus x plus 8 dx. Okay, so this is a long problem. All right, so so the limit definition is that the area A under the curve y equals f of x from 1x y so there is equal to the limit as n approaches infinity of f of x sub 1 delta x plus f of x sub 2 delta x plus dot 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 plus f of x sub n delta x. Okay, so it's the limit of that. Okay, that's the area. So we're going to use that to find the step interval. So this equals the limit as n approaches infinity. Another way to write this, right, is using summation notation. So this is equal to the limit as n approaches infinity of the sum from I equals 1 to n of f of x sub I delta x. Okay? So that sum you can write as this sum notation. That represents the entire sum. Okay? That's a summation notation. So the question's saying using the limit definition to evaluate this. So you want to equals the limit of the sum from I equals 1 to n of f of x sub I delta x. Okay? And so calculating this is evaluating using the limit definition. But this is where x sub I is equal to a plus I delta x and delta x equals b minus a over n. All right? So we're going to use that. So here a is this and b is that. A is 1, b is 3. So delta x is b minus a over n. That's 3 minus 1 over n. That's 2 over n. Delta x is 2 over n. X sub I is equal to a plus I delta x. A is 1, so this is 1 plus I times delta x, which is 2 over n. So x sub I is 1 plus I times 2 over n. For I equals 1, 2, 3, dot, 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 up to including n. Okay, so that's xi for all the i's from 1 to n. Okay, so this is equal to the limit as n approaches infinity of the sum from I equals 1 to n of f of that, f of 1 plus I times 2 over n times delta x, which is 2 over n. Okay? Delta x is 2 over n, and x sub I is 1 plus I times 2 over n. That's directly from the limit definition. The limit definition of the integral. Okay? This is equal to the limit as n approaches infinity of the sum from I equals 1 to n. F of something is that something squared minus that something plus 8. So we're just going to plug in that into here. Okay? I'll erase this. Okay. This is F plugging in there. So you get 1 plus I times 2 over n squared minus 1 plus I times 2 over n plus 8. Times 2 over n. Okay, so now let's multiply this out and combine like terms. This equals the limit as n approaches infinity of the sum from I equals 1 to n of that squared is 1 plus I times 4 over n plus I squared times 4 over n squared. So that thing squared is that. Okay? So it's multiplying, okay, and then it's minus 1 minus I times 2 over n, okay, so you might need practice doing this arithmetic, okay, but it's just arithmetic, okay, and so then times 2 over n here, times algebra, just basically, okay, so equals the limit as n approaches infinity, the sum from I equals 1 to n. 1 minus 1 is 0. You have an 8 here, so let's keep the 8. Here's the 8. Good. Now the I term, we have I times 4 over n and minus I times 2 over n. So it's I times 2 over n plus I times 2 over n. That's this term minus that term. What we're left with is this one term. And so we have plus I squared times 4 over n squared. Okay, so it's the limit of the sum of that. And so now when we get that, it's the answer. So I think I'm going to write this. Okay, so this equals the limit as n approaches infinity. Now I'm going to separate the sums. So first is going to be 8 times the sum from I equals 1 to n of 1 plus 2 over n times the sum from I equals 1 to n of I plus 4 over n squared times the sum from I equals 1 to n of I squared. It's the limit of that. Okay? N is a constant because the sum is we're summing over I. So anything other than I is a constant. Even n is a constant. This is just a number here, or a variable representing a fixed number here. I is the only variable. So anything that's not I is considered a constant. So 2 over n is a constant, 8 is a constant, 4 over n squared is a constant. And so the sum of 8 is 8 times the sum of 1. Adding up 8s is the same as adding up 1s and then multiplying by 8, okay? And then the sum of I times 2 over n is 2 over n times the sum of i's. And then the sum of I squared times 4 over n squared is 4 over n squared times the sum of I squared. Okay, so we have, now what you have to do is you have to substitute the value of that sum, the value of that sum, and the value of that sum in there. And you'll get an expression of n that you can take the limit of. Okay, so this is going to equal, I'll put a star here, because I'm going to continue this over here. Okay, so let's continue that over here. So this is equal to the limit as n approaches infinity of 8. The sum of 1 n times is just n. Oh, okay. Wait, this is times 2 over n. This bracket is times by 2 over n here. So there's a 2 over n right there. I saw that because when you get an n here, it doesn't cancel with anything. So to fix that, I'm just going to fix that. It's very easy to fix. You're just going to take what's in the bracket is being multiplied by 2 over n. That's still the bracket. So you're just multiplying this by 2 over n. And so this limit is equal to the limit. Now, we're going to multiply the 2 over n. So this is n. So you get 8n, 8 times n times the 2 over n here, plus the sum of I from 1 to n is n times n plus 1 over 2. So you have 2 over n times 2 over n. You have 4 over n squared times n plus 1 over 2 plus 4 over n squared times 2 over n is 8 over n cubed times, the sum of the squares is then n times n plus 1 times 2n plus 1 over 6. This is equal to the limit as n approaches infinity. The n's cancel, and you get 8 times 2 is 16. 16 plus 4 over 2 is 2. N over n times n plus 1 over n. Plus 8 over 6 is 4/3 in simplest form times n over n times n plus 1 over n times 2n plus 1 over n. Okay, so the limit of this plus this plus this, and that's equal to, so continuing here. Okay, so now I'm going to calculate the limit of a constant is that constant. 16 plus 2 times 1 times 1 is 2, plus 4/3 times 1 times 1 times 2. That's 4/3 times 1. The limit of 1 plus 1 over n is 1 plus 0, which is 1. And the limit of 2 plus 1 over n is 2. That's 2. So this is equal to 16 plus 2 plus 4/3 times 2, which is 8/3. And that's equal to 18 plus 8/3. So that's 20 and 2/3. So that's 62 over 3. Okay, 16 plus 2 plus 8/3 is 16 over 3. So it's 18. This is 2 and 2/3. 18 plus 2 and 2/3. 20 and 2/3. That's 62 over 3. Okay? You just calculated anything, 3 things. And that's 62 over 3. Okay. So that is the answer. Okay, so there's one problem. Okay, so number 8. So remember the sums here. The sum the sum from I equals 1 to n of 1 is n. You're just adding 1 n times, and so you get n. Here, the sum from I equals 1 to n of I, which is 1 plus 2 plus 3 plus dot 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 plus n. That's n times n plus 1 over 2. This sum is that n there, which cancel out that one. This sum is that there. This sum is that there. The sum from I equals 1 to n of I is n times n plus 1 over 2. The sum from I equals 1 to n of I squared is n times n plus 1 times 2n plus 1 over 6. Because there's formulas and you plug them in, so that's memorization. You can memorize it. There's ways to prove it too. But so that sum is n, that sum is that, and this sum is that. And you plug them in, and you multiply out, and then at the end you take the limit. And here, when you took the limit, right, I took the limit of this guy, and I took the limit of this guy, and I took the limit of that guy. The limit of those things, right? If you take the limit as n approaches infinity of n plus 1 over n, right? That's the same as the limit as n approaches infinity of 1 plus 1 over n. N over n is 1 plus 1 over n. Now the limit of 1 plus 1 over n is 1 plus 0, which is 1. The limit of 1 over n is 0. So the limit of 1 plus 1 over n is 1 plus 0, which is 1. Okay? So I use that here because I calculate that limit to be 1 and the limit of that to be 1 over here. Okay? The limit of that is very similar. The limit as n approaches infinity of 2n plus 1 over n is equal to the limit as n approaches infinity of 2 plus 1 over n. Because 2n over n is 2 plus 1 over n. And so the limit of 2 plus 1 over n is 2 plus 0, which is 2. So the limit of this is 2. And so that's why this was a 2 here. Okay? And the limit of this guy was 1. N over n is 1. The limit of the constants itself. Okay? Alright, so then this is how you do this kind of a problem. And the answer is 62 over 3. So that's number 8. Okay, number 9. Determine the volume of the solid obtained by rotating the region bounded by y equals x cubed, y equals x, y equals x cubed, and y equals x. Okay, so I'm just going to draw this a little bit. Draw y equals x. Then y equals x cubed. That goes through the origin. Y equals x cubed. Well then, there we go. Draw y equals x first. Okay. So y equals x cubed looks like that. This is the intersection point 1, 1. Between x equals 0 and x equals 1, x cubed is below this. And then after x equals 1, it goes above it. Okay, so we're going to take the region bounded by those two curves and we're going to rotate it about the line x equals 3. Okay, so here's x equals 1, that's x equals 2, that's x equals 3. So here's the line x equals 3. And so if we take that region, that shaded region, and reflect it at the line x equals 3, then the mirror image we get is kind of like this. Okay, so now we're rotating it, and so here's the circle, here's the other circle. Okay, and we're going to use cylindrical shells. Okay, so using cylindrical shells, you take a vertical line in your shade region. I chose this vertical line, not the other way, because now this is going to stay the top function, and this is going to be the bottom function, right? This is the top function here, which is this. This is the top function, and then this is the bottom function, and it stays constant throughout. This is always the bottom function in this shade region, and this is always the top function in that shade region. That's the top function. That's the bottom function. Okay, and so now that's the mirror image of that vertical line. And when you rotate that vertical line about x equals 3, just like you do the entire region, you get a cylindrical shell. Okay, and so the volume of that space rotated around, the volume of that three-dimensional space, is equal to definite interval from the smallest x value, which is 0, to the largest value, x equals 1 of the shade region. It's integrating with respect to x because the thickness of the vertical line, right, is a delta x, is a change in x. So it's definitely from 0 to 1 of the top function, which is x, minus the bottom function, which is x cubed, dx. Oh, no, wait. Sorry, we're using cylindrical shell. So it's 2 pi times, right, when you take a cylindrical shell like this, the volume of it, this is an infinitesimally small so the volume of a cylindrical shell is equal to, here's the radius, is equal to 2 pi r, that's the height here, 2 pi r h delta x, where that's delta. That's if the cylindrical shell is faced vertically like this, which this one is. It's just thick, it's like wide, but still vertical. The height is going up. Okay, so the cylindrical shell oriented this way, it's like sitting up like a normal one would, just like kind of thin and like wide, like not short and wide, right? That's values, but still standing up. So the volume is 2 pi r h delta x. So what is the radius? The radius of our cylindrical shell is the length of this line segment. Well, if you look at this point, right? This point, its coordinates are x comma y, and it's a coordinate of a point on the line y equals x. And so that x coordinate, that x distance, and so that x distance is, this distance here. This whole thing is 3. And so if that's x and that's 3, if you take away x from 3, you're left with 3 minus x. And so the radius here is 3 minus x. The radius is 3 minus x. If you have this distance, which is 3, and you take away the x, 3 minus x is 3 minus x. So the radius is 3 minus x. So the radius of our cylindrical shell is 3 minus x. The height of the cylindrical shell is the difference of the top function, which is x, minus the bottom function, which is x cubed. And so this is 2 pi r, 2 pi times 3 minus x, the radius, times the height, which is the top function x, minus the bottom function, x cubed. So 2 pi r h dx. So you calculate that definite integral, and you then have the volume of that three-dimensional space. Okay, so now this is equal to 2 pi times the definite from 0 to 1 of that times that. What you get is 3x, that times that is 3x, minus 3x cubed, minus x squared, plus x to the 4th dx. I just FOILed that out. You get the sum of 4 products there. Okay, and so there's no common terms, and so we can now start integrating, find an antiderivative, use the evaluation theorem. So this is 3/2 x squared minus 3/4 x to the 4th minus 1/3 x cubed plus 1/5 x to the 5th. And we evaluate it from 0 to 1. This is equal to 2 pi times plugging in 1 minus plugging in 0. So if you plug in 0, it's nothing. So you just plug in 1 and that's it. So you get 3/2 minus 3/4 minus 1/3 plus 1/5. So plugging in 3/2 minus 3/4 minus 1/3 plus 1/5 and then minus 0. And so 2 pi times that is, so a common denominator is 30 for those 4 fractions. So if you add those fractions, you're going to get 45. No, it's 60. Sorry, common denominator is 60. Least common denominator is 60. So, okay, so 3/2 is 90 numerator there, minus 45, minus 20, plus 12. So that's 3/2 minus 3/4 minus 1/3 plus 1/5. So you get 90 minus 45 is 45, 45 minus 20 is 25, 25 plus 12 is 37 over 60. And so that's 37 over 60. So it's 2 pi times 37 over 60. That's 37 over 30 pi. Okay? Okay, sorry, so you multiply that by 2 pi, and instead of 2 over 60, it's 37 over 30. Okay, so 37 over 30 pi. That's right. So final answer is the volume is 37 over 30 pi. That's number 9. Okay, so we use method of cylindrical shells for this problem. Okay. Number 10. So number 10, number 10 is differentiate the function. So f of x is equal to cosine x raised to the sine x. Take ln of both sides. So ln, so I'm going to let y equal f of x here. So ln y is equal to ln of cosine x to the sine x. Okay? And so by the third law of logarithms, you can move the sine x in front. You get sine x times ln of cosine x. Okay, so using logarithmic differentiation, and so we have ln of y is equal to sine x times ln of cosine x. Now differentiate that equation with this equal that implicitly with respect to y. You get 1 over y times y prime, ddx of ln y, is equal to ddx of this. This is the first function, that's the second function. So you take the first function, sine x, times the derivative of the second function, which is 1 over cosine x, times the derivative of cosine x, which is negative sine x. That's the first function, times the derivative of the second function, plus the second function, times the derivative of the first function, which is cosine x. Okay, so we have 1 over y times y prime is equal to that. If you multiply both sides by y, you're solving for y prime. And you get y prime is equal to y, which is cosine x raised to the sine x, that's y, times this, which is, this is negative sine squared x over cosine x plus ln of cosine x times cosine x. And that's y prime. This is a negative sign here. Okay, make it clear. That's a multiplication sign. That's a minus sign. Okay, and that's y prime. And so now we've solved for y prime, and that's the answers to the problem, number 10. All right, so these are the answers to the 10 problems in the practice final. Okay, so I'm going to include other stuff to help with your review. Okay, so see you in the next video.